In this Zoom video, I'm going to work problem 1 of 4.1, lesson 4.1. And in that problem, there's some things that you need to know before you start the problem. So I'll go over those first. And one of the things that is asked for involves right skewed or positive skewed, and we need to know what that means. As you can see here, I have a histogram or a bar graph. Okay. Now, depending on how this bar graph is situated, depends on whether or not we're skewed to the right or skewed to the left. First of all, if you select the highest bar, okay, then we will say that's the peak of the distribution. And we'll break the distribution up into the peak, the right side, and the left side from the peak, okay? Now, when we go on either side of the peak, these are called tails. So I have a right tail, it's on the right side of the peak. I have a left tail, which is on the left side of the peak. And depending on the number of bars that are in the tail, determines whether you're right skewed or left skewed. And in this particular case or example that I have here, there's 1, 2, 3 bars in the right tail and 1 bar in the left tail. And that happens when the larger number of bars appears in one tail or the other. That determines whether or not the distribution is skewed. Since the higher number is in this tail, and it's to the right of the peak of distribution, which is the largest, the highest bar, it's said to be right skewed. So in this particular, if this was your histogram, it's associated with your data set. We would say that this is right skewed or positively skewed. What do you mean positive? Well, on the right side, you're going in this direction. On the left side, you're going in the opposite direction. So we would say this is positive direction. Remember on the number line in algebra, going in this direction is in the positive direction. Going in this direction is the negative direction. So let's just talk a little bit about this. The tail has more bars on the right than on the left side of the peak. That's why it's called right skewed or positive skewed. Positive because it's in the positive direction. The tail is in the positive direction, which is what I talked about, from the peak, which is the bar that's the tallest. Okay. Now notice, I want to talk to you a little bit about this. When you have a right skewed distribution or a histogram associated with a distribution, the mean will always be larger in value than the median. The mean will always be larger in value than the median. Now, when we go back to the problem, I'll discuss what we mean by mean and median. But this is what I want you to know before we get the problem started, okay? Now, let's take a look at left skewed. The left skewed, in the left tail, because here's the peak, we have a left tail and a right tail. In the left tail, we have 3 bars, and that's in the left tail. The right tail, we only have 1 bar. So since there's more bars in the left tail, this is said to be left skewed. Or from the peak of the distribution, it's in this direction. See? So we would say that it's negatively or negative skewed. So it's left skewed or negative skewed. You can refer to either way. Now notice something about a left skewed or negative skewed distribution. The tail has more bars than the right side of the peak. It has 3 here, 1 here. So that's why it's left skewed, okay? The tail is in the negative direction, in this direction here, going towards a negative infinity on the number line, if you want to think about that. Okay, so it's in that direction from the peak. The mean will be less than the median. We'll talk a little bit more about that. You might write that down in some notes, so when we work the problem, you'll understand what we referred to. Now, I know some of you are going to say, well, what if it isn't? What if they're the same? What if the number of bars in the left tail is the same as the number of bars in the right tail? Well, guess what? If that's the case, the right tail has 2 bars, the left tail has 2 bars. Here's the peak. In that case, it's 0 skewed. Now, the number of bars on either side is the same when it's 0 skewed. The mean will be equal to the median. The mean will be equal to the median. And the bar graph is symmetric about the peak. In other words, if we were to take and fold the paper right down the middle of this peak bar, the right-hand side would fall directly on the left-hand side, and that's why we say it's symmetrical. In that case, if this is what happens with your bar graph or your graph representing your data set, then we say that the data set is normal. Plays a very important role in statistics. When we have something that is normal, it allows us to state a lot of theorems. It helps us to get through some of the theory involved in statistics. So, okay, now we've discussed that. And I'm going to go now to the problem and work the problem. Just keep that in mind because you'll need that when we work the problem. Okay, so now what we will do is share our screen, and here's what your problem looks like. It's problem 1 of 4.1, describing the center of a data set. Our data set happens to have 6 entries in it. Okay? And not only does our data set have 6 entries, but if you look at some of the entries, there's 196 is quite larger than the rest of them. And if you have a value that is larger than the rest of them, or less than the rest of them, it's called an outlier. In statistics, it's called an outlier. And 196 is called an outlier because it's larger than the other values in the data set. Now, when you see use SALT, your author is saying, I don't want you to find the average by adding them all up and dividing by the number, which is 6. I just want you to use the calculator that I provide called SALT. SALT is what is called a stat pack that allows us to use the stat pack that will give us the answers very quickly. Now, you say, well, how simple is that? No, I didn't have to do anything but punch a couple of buttons and write down the answer. That's true. In my day, when I had to do a problem like this, I had to do it longhand. Well, it was all right when we had 6 entries in our data set, but sometimes they would throw something that had 50 entries in our data set. That means I had to find the mean, I had to add, because the mean means average, I had to add all 50 of them up and divide by 50. And back then, we didn't have the nice calculators that you have now. So it took us a long time just to do one problem. A lot of times we would make a mistake. It'd be easy to make a mistake. And so if you're out in the field and you're doing statistics, I'll guarantee you, you're going to use a stat pack. You're not going to sit down and do everything wrong. This takes too much time and it's too easy to make a mistake. So to work this problem, I'll be short-winded here. What I'll do is I'll click on the stat pack. Now your author has already loaded. When you click on that button, it automatically transfers the data from web assign, which is where you do your homework, into Salt. So now the data that appeared, the 6 that appeared, if you check, these are the prices that were given in our problem. Okay, problem 1. Now, the neat thing about this, we can find out a lot of information from the SALT. It's called Statistical Analysis and Learning Tool. Will do the problem for us. We can just write down the answer. So click on Descriptive Statistics, and voila, there's your mean, and there's your median. Okay. Median means the center value of the distribution, and the mean is the average of the values in the distribution. Okay, so let's write those down, and then we'll put it into our problem. So if you're following this, doing this at the same time that I'm explaining it, when we get through, you got the problem done. And we're supposed to round it to the nearest cent, $148.57, because 3 is not larger than 5, so we'll just opt for 3. And we have 148.57 or $148.57 for the mean. And the mean and the median, which is the center one, is 143.23, because we have 5 in the third decimal place, and that 5 or larger, you'll go to the decimal place or just before that and make it 1 larger. So that's the rounding rule. $143.23. Now, remember that we're going to be also asked about whether it's right skewed, left skewed, and that sort of thing. Now I'm going to click on the data here. You have to select the variable, which is price. And you can see this is the histogram. It's underlined. And notice, here's the peak bar. There's nothing on the left. And on the right tail, there are 2 bars in. 2 bars, maybe more than 2 bars. Okay. So we would say that this distribution of the 6 prices that we have is right skewed or positive skewed, because there's more bars in the left tail than there are in the right tail. Okay? Now, let's go back to our problem. See if we can answer the problem, some of the problems. Okay? So we'll share our screen. And we'll put in 148.57. and 143, 23. Okay. Now let's go to the next problem, next down here. Why are these values so different? Remember, if it's skewed to the right or skewed to the left, the mean and the median are not going to equal one another. If it's skewed to the right, the mean is going to be larger than the median. Remember that. If it's skewed to the left, the median is going to be larger than the mean. So why are these values so different? The distribution of this set is positively skewed or skewed to the right. Okay? Now, the next one, which of the two, mean or median, appears to be better as a descriptive typical value of this data set? Well, because of the 196, which is an outlier, that affects the mean. So probably the best representation is the center of this distribution. And the center value is not influenced by the extreme value. So that happens to be the answer. Okay. Now, let me go back because I don't know. I use Zoom at another university, and if I click on when I'm sharing a screen, click on it, you can't see it. So what I'm going to do is I'm going to click on it. Okay, you won't be able to see that value, so I'll stop sharing, and then I'll share again. But I'll go back and share with you what it looks like when you click on using. And that's what it looks like when you're using salt. Okay. Now, to get the mean and the median, I click on descriptive statistics. Now, you're not going to be able to see it, so what I'll have to do is click on it. Sorry about that, but that's just the way this works out. Okay. Now, I'll stop sharing. Go back and share, but I'll share the one that shows the answer. So you see, you have the mean and you have a median. You can round them to the nearest cent. Okay. Now, where did I get the graph? Well, charts and graphs. I'll click on it. You won't be able to see it right off. You have to do select the variable. And then I'll stop share and share again. And when you do, you see the histogram, and the right tail has 2 bars and the left tail has no bars. So this is going to be positively skewed or skewed to the right. Okay, let's stop sharing. And now back to the problem. You have the distribution is positively skewed, and you saw that from the histogram. And you also know that since 196 is larger than the rest, that the median is a better representation of the data than the mean. Okay. Now I want to just mention to you up here, if you remember right, when it's right skewed, the median or the mean is going to be larger than the median. If it's left skewed, the median is going to be larger than the mean. So, okay. Well, that's problem number 1.